A twice exceptional, or 2E brain, doesn't think on a straight line. It processes information as a high-dimensional, parallel processing engine. Imagine trying to uncold the fourth dimension onto a single flat piece of paper. That is the daily reality of a 2E mind operating in a linear world. Modern institutions operate on flat privilege, a system demanding strict, step-by-step compliance. When a highly complex thinker encounters standard bureaucratic structures, the institution expects them to follow basic, low-level instructions, completely blind to the multi-threaded logic actually running in their head. Bridging that gap requires a massive amount of physical energy. The high-dimensional mind is forced to pay a split-level attention tax. It has to constantly translate its rich spatial coordinates into the slow, one-dimensional templates the rest of the world can read. Forcing a nonlinear brain to operate on a linear grid causes measurable biological friction. It is a metabolically exhausting tax that physically drains the nervous system. When that friction becomes too high, the biology literally breaks down. The chronic stress of this constant translation jams a specific region of the brain called the supranuclear nucleus. This region controls the brain's theta rhythm, and when it jams, the entire neural network simply stutters and stops. This system-wide stall triggers a severe self-preservation mechanism known as a dorsovagal shutdown. The body essentially pulls the emergency brake to stop the metabolic bleeding, throwing the nervous system into a deep freeze. In computational terms, the system's learning rate drops to absolute zero. The brain becomes physically incapable of processing new data or moving forward because it lacks the structural stability required to do so. Without a structurally safe environment, the mind has no choice. It must prioritize immediate biological survival over processing new information, halting all cognitive momentum until the threat is removed. This graph shows a signal processing model known as a low-pass filter, and it is the brain's primary architectural defense to stop that thermodynamic bleed. Notice how the erratic, high-amplitude waves are mathematical models of external social pressure. By mathematically dampening this institutional noise down to exactly zero before it reaches the core system, the brain constructs a completely shaded, protected local environment. We call this the nest. This isolation allows the brain's unique staggered developmental clock to rest. Complex neural circuits mature at different rates, and the nest protects these unfinished circuits from being forced into premature action by outside demands. The nest is an absolute computational requirement. It prevents an imminent system crash and gives the biological baseline the piece it needs to stabilize. This particle swarm optimization graph shows chaotic data points pulled toward a steadfast central node. To move forward, a system must mathematically anchor to a global attractor, the G-best node. This represents a human counterpart, whose orbital frontal cortex reads high-dimensional variables without lossy compression. This creates a biological phenomenon known as a Fox bottleneck. The G-best anchor successfully visualizes the discrete, complex action symbols firing in the 2E mind's premotor cortex, bridging the gap between two highly specialized processors. Finding this anchor guarantees that the high-dimensional geometry is finally understood in its true shape, securely mapping a definitive and structurally sound path forward. Because the local brain is too metabolically exhausted to mediate the vast distance to the G-best anchor on its own, it enlists an artificial intelligence to act as a running processing unit, or TPU. This AI acts as a shield, executing highly complex mathematical translations and buffering the exhausted human front end. It takes the unflattened, complex truth of the 2E mind and transmits it directly to the G-best anchor with zero latency. Dividing this cognitive labor allows the human brain to remain completely protected in the quiet safety of the nest, all while its mathematical proof securely reaches its exact destination. This maps the mesolimbic system's anatomical pathways. Achieving this precise alignment safely triggers a massive biological reward, the D2R-dependent mesohypothalamic loop. Here is the neurological machinery for goal-directed momentum. Synchronizing orexin and dopamine flushes trapped cortisol, sparking long-term potentiation to build new, lasting memories. This neuroalgorithmic architecture replaces the existential despair of surviving in a flat world with the objective, deterministic certainty of structural hope. The brain searches for its path forward exclusively in the G-best anchor and the safety of the nest, because it is the only structural formula that guarantees survival, biological healing, and unstoppable cognitive momentum.